Hello and welcome to Engineering with Rosie Live and welcome to 2023. I hope you all had a good break over the new year. And please, as always, let me know if you can see and hear me because I always have a fear that I am doing something wrong and talking to myself. So, yep, looks like you can see me. So thanks, Lorenzo, for letting me know. So in the live stream today, we're going to talk about hopes and predictions for energy transition news in 2023. And as someone commented in one of the posts I did before this live stream, it's sometimes very hard to tell the difference between hopes and predictions. So I'll probably say this is more like my hopes for 2023 in energy transition news. And why don't you tell me in the comments what you think will or won't be big news in the energy transition this year, and obviously what you hope will be or won't be. So I'll start by thanking the sponsor of these live streams, WeatherGuard Lightning Tech. WeatherGuard makes strike tape, which is a retrofittable lightning protection system for things that go fast, like wind turbine blades and aeroplanes. And these live streams wouldn't happen without their support. And the whole Engineering with Rosie channel, in addition to the sponsors, the whole Engineering with Rosie channel is supported by the amazing Patreon community. So thank you to all of them. Okay, so actually I am now wondering whether everything is okay because I haven't got a lot more comments. So keep them coming through, please, if you can see and hear me. Don't be shy. Okay, so I'll start just by showing some of the comments that I got. I asked on the community page on YouTube, what are the predictions for biggest energy transition trends in 2023? And I'll just go to comments. So we've got Nightlight78 posted, wants to see how far we can push wind in the UK. And yeah, some moments generating more than 60% electricity, lots more coming on this year. So that will definitely be a trend to watch, and the UK is pushing that really, really quickly. Yeah, and then actually this one I really liked from Danksbane, working offshore wind developer. I'm thinking this will be the year where a lot of us start to face the reality of price increases over the last year. And I know, from anyone working on delivering renewable energy projects, it's getting harder and harder to, deliver at the prices that projects were agreed to. Harder and harder to actually get your hands on, all of the turbines and everything else that you need to put projects in. So I think that that's definitely going to be key. And then a comment on solar, and especially solar for rooftop. And he's talking specifically about India, but I think that is a problem in a lot of places, but interestingly, not so much a problem in Australia. We just continue to roll out rooftop solar really, really fast. So that might be an interesting video actually to look at why Australia can actually get those kinds of projects done quickly and cheaply compared to other places. This is who I was talking about before. Thomas Bensler says, predictions, wishes, hard to not let them mix up. Wish long-term storage at scale. Yeah, I think me too. I wonder if 2023 is the year for that, though. I think maybe more announcements of projects starting, but to be honest, not many places need long-term storage at scale because no one is really relying purely on variable renewables at the moment. And then over in Twitter, I also had some interesting comments on a post there. I kind of seeded the discussion by starting with a couple of possibilities. Desert solar farms exporting via subsea cables, carbon capture and storage becomes economically viable, electricity generated by renewables overtakes coal globally, new nuclear power plant announcements. Not sure I believe any of those are going to happen, except for maybe electricity generated by renewables overtakes coal globally in terms of actual megawatt hours generated. I think that's set to happen sometime in the next few years anyway. Nuclear power plant announcements. Yeah, maybe announcements, but obviously you can't deliver projects in that shorter time frame. And I think the same for the others. And the carbon capture one I put in there because the price for carbon in places that have a price on carbon, it has risen to the point where you should be starting to see carbon capture and storage be economic without government subsidies, but I haven't seen the rush in companies announcing that they want to make these very financially attractive projects yet. So it makes me a little bit suspicious about about those estimates for how much it should cost. And Twitter, we had a lot about nuclear, batteries, photovoltaic, thermal, wave, lots of different options. Okay, so now I might go and see what comments that we've got from you guys. I've got Murray Robinson and is attending his first live stream. Hello, Murray, and thank you for confirming that you can see and hear me. Colin Keitzer says he hopes we can find a capable small wind power device optimized for the backyard, a very cluttered environment. I'll install several of them attached to a camping style battery pack. Yeah, a lot of people want that, and I made a video on urban renewables. Let's see if I can actually find my channel. So I did, where was it? I did do this one here, rooftop renewables, solar versus wind. And that is all about the energy resource for solar versus wind power, and talks a lot about some kind of hard physics boundaries that you come up against if you are trying to put wind energy in your backyard. It's probably a little bit of a negative thing. But there have also been some positive announcements in that space. I know the US has made a push for small scale renewable development, and it'll be interesting to see where that goes. I might try and look up the article later on, or in another live stream. It might be a good topic to follow because people always ask me about that one. Okay. Jonathan Maddox says CCS is a pure additional cost to any fossil fuel project, which is necessarily cheaper without it. The only way it's viable without subsidy is if a high emissions penalty is taken for granted. Yeah, exactly. But it's been a little while since I have been researching CCS. I kind of got halfway through trying to do a big deep dive on blue hydrogen specifically, which is manufacturing hydrogen from natural gas and then capturing the emissions. And when I was diving into that a couple of years ago, the price that the carbon capture people were saying that they would need a price on carbon to be before it was economically viable it's pretty close to the level that it's at now, and it's certainly predicted to go higher than that in the near future. And so I've kind of been keeping an ear out, like, okay, well, guys, you've got what you said you wanted at this price, then it should make economic sense. And I guess you can debate whether it's really without subsidy if it relies on this quite high price on carbon. But yeah, we are kind of at that level or close to it, and we're still not seeing the announcements. So. Yep. Okay. Lots of people saying their first stream. Yes. Okay. Anyway, that's some good comments for now, and keep them coming. So I want to just go through, 2 or 3 predictions that I have for this year, and they're really a wish list. The first one is the increased presence of like home generation, and I'm going to borrow a term from a company, RedEarth, and call them private power plants, PPPs, or also you could call it personal power plant. So I have talked about them before on the podcast that I co-host, but I just wanted to show here. Here it is. This company, RedEarth, they have a really interesting approach to, the idea the idea is that we've got all this distributed generation in people's homes, so solar panels, sorry, soon electric vehicles, hopefully with vehicle to grid technology, or at least vehicle to home is coming. And in the previous live stream, I showed that, a bunch of manufacturers now are announcing that going forward, all of their cars are going to have that capability. So that's coming soon. Home batteries, and then even some crazy things like, where is it? Yeah, this Channing Street Copper Company who's making induction stoves that have a battery built in, which maybe sounds crazy, but makes a whole lot of sense because especially in the US where they only have 110 volts to work with, you can't just plug an induction stove into 110 volts because when it's at its peak output, then it's drawing a whole lot more than what you can get out of 110 volts. So they're putting batteries in there that will allow you to run the stove off 110 volts, but it's charging the battery, and then when it needs more than that, then it can draw it from the battery. But you can also do cool things like connect your fridge to it. So in the event of a blackout, then you would be able to run your fridge for a few days off the stove. So this is kind of just the first, I think, of many appliances that we're going to see with batteries in them. Anything where, you can't just plug it into your regular outlet or the regular voltage. We'll start to see batteries. And then, of course, when you've got all these batteries sitting around, then that's a source of value. And one of the criticisms that people have always raising with me, and I see it in the media a lot, about why we don't have, all of this demand response and, the households playing in energy markets, is because it's too complicated and, it relies on somebody needing to control a bunch of stuff. Like, you might be able to either draw on power from your induction stove or from your power wall or from your EV, but you can also get a similar effect by turning down your air conditioner or, anything else that's drawing a lot. And I think that a really interesting approach is the way that this company RedEarth is doing it. So it's kind of like gamification of it. So they've got this app and you can see, I think I've got some screenshots here. You can see right in the app how much, like what the current price of electricity is, and you can, predict in the future what it's going to be and change your energy usage and say when you want to send power from your battery into the grid. And then you can make money off it, and it will tell you how much you're making every day. And I think that 2023 is going to be the year that this sort of system finally starts to, get some mainstream adoption. RedEarth have been around for a while, but I haven't really seen it taking off in the way that I have been saying for years. I think this is going to be a big thing, and it's going to be a big help for the grid as we go through the energy transition and have a whole lot of variable renewables in. It will really help if we're using energy in a smart way, as well as, just relying on a lot of battery storage to fill out those peaks and troughs. Yeah. Okay. So let's see if any of you have anything to say about that. Got Oleg says freaking early for Europe today. Yeah, sorry, it's inconvenient time of year to work between Australia and Europe. So sorry if you had to get up early, but thank you for being here. And it's super hot here, by the way, in case you can see, I'm going to start sweating. So yeah, you can see it's a hot day here. Okay, Murray Robinson asks, could a stove be a candidate for a home-scale thermal battery system? Gee, I don't know. I mean, a home-scale thermal battery system is also something that could be part of this whole concept. And I actually don't have a name for the whole concept. I haven't heard any good catchy ones. Maybe if you have, then you can tell me. But yeah, the idea of no, it's not just distributed energy. It really is the idea that the home's going to be virtual power plant, or not a virtual power plant. It's a personal power plant, but that, you're going to be energy trading on the home scale, whether it's just for you or it's going to be done automatically. Oh, and actually that reminds me, there was another company, or I think it's a not-for-profit actually, called What Time. They're another interesting one that I heard about recently. And what they're doing is they've got some algorithms that will help appliances to know when is the cleanest, like what's the cleanest way to use electricity over the day. So, if you've got an air conditioner and that it needs to be on 15 minutes in this hour, but it doesn't matter which 15 minutes, then they can predict when that is likely to be a good time for you to turn it on, when the next generator that's going to come on because you have increased your load is going to be a clean one. And the reason why this is interesting is because they've got some arrangements with like Nest and a few other device manufacturers like that, so that integrates, and it doesn't cost a consumer any more. All it does, and it doesn't cost them any effort either, all it does is just makes their electricity consumption a little bit greener. So that's why, one of the reasons why I think that 2023 is the right time for this to go mainstream, because it's kind of finally gotten to the point where they're like, oh, it's not such a pain as it sounds like it has to be. Companies are starting to figure out how to make it easy for everybody, and like RedEarth and other companies like that have figured out how to make it, put money in your pocket, in the consumer's pocket. So yeah, that will be interesting. But yeah, to get back to Murray's point, I think that one of the other devices, I just realized I was not showing my screen that whole time, but this is the What Time system that I was just talking about. But yeah, so another device that you could definitely include in this whole system would be hot water. If you're heating that with like a heat pump or any other kind of electric heating, then your hot water system, if you've got a tank, that's basically a thermal battery. And I know that those kinds of systems have been around for ages and ages, and not very exciting maybe, but now is the time where we're starting to need that more and more. So I think that will make a comeback. Okay, more questions. Some a bit philosophical. Oh, Colin Kites has got a good one. Check out 2-Bit Da Vinci on the recent California regulation changes that directly impact energy arbitrage. I will. I have not heard of that, so I can't say anything about it now, but maybe somebody else can in the comments. Okay, a question from Stephen Wolf about geothermal. It's interesting that you have recommended someone. I haven't seen that TED Talk, but geothermal is on my list. I actually have already started writing the script for that one, and I am looking for experts, so that's actually a very super useful point, so thank you for that. Peter Ross says nanogrid. Is that what you're saying I should be calling, like a personal power plant, or is that a prediction for the future? In which case, what do you mean by it? Okay, more about geothermal. Okay, here's one from Procrastination. That's a funny name. And another topic that I am planning to make a video on this year, but I haven't started it yet. Will the cost of battery recycling or disposal go down as adoption becomes more widespread? If not, what are some potential consequences? I think definitely my understanding of battery recycling is its main problem is that there aren't enough batteries to recycle at the moment. So before it can really get cost effective, you need to have good supply of batteries to recycle. And at the moment, they're tending to last longer than people probably expected. Car manufacturers, for example, tried to be quite conservative with their lifetime estimates at first so that they wouldn't end up disappointing or having to replace a bunch of batteries under warranty. But yeah, my understanding is that people have been surprised and pleasantly at how long their batteries have lasted. And then of course, once the car's life is over, or the battery doesn't have enough lifetime for the car, then you can still use it in a stationary application. There's plenty of companies around doing that. And so, yeah, we can recycle batteries, and there have been some interesting milestones achieved with some of the companies working on that recently that I'll cover when I make a video. But I don't think that we're going to see it super mainstream until, 10 years time, when a lot of car EV batteries need to be disposed of, which we're kind of just not at that point yet. Okay. Another interesting one. Comment from Reckless Stas. Where do you think the offshore wind and HVDC industry are headed in Australia in the next few years? Will those HVDC links need to be grid forming at the NIM end? Don't know so much about the HVDC part of it. Something I can look into, but don't know for now. But offshore wind, very exciting. We finally have the Star of the South got announced as a, what do they call it, like a project of national importance or something. They have some special name for it, which means basically that the government is going to smooth the way for it to all get rolled out. So I'm really excited for that, and I really hope that I would get the opportunity to work on that project in some way. So yeah, very, very exciting. Okay, let's... good point from Oleg. Hot water tanks with phase change materials are finally getting cheaper for homeowners. It's a better way to store heating at home. It's interesting. And another topic I want to focus on or do a video on this year will be domestic stuff like for buildings, energy efficiency, and like architectural things and stuff like that. And that would be part of that. Okay, and Colin thought raises an interesting point. It'll be interesting to see whether the big semi-trucks and city battery banks wear out batteries faster than cars, and you're probably right that they will, because they're just cycling them constantly. Okay. And then Richard Warren has made a donation. Thank you. We need more focus on how households can reduce the usage. It's the number one way to get to sustainability. And I definitely 1,000,000% agree with that. It's one of the things that I have been puzzled by basically the whole time that I've been working in renewables. It's really obvious that energy efficiency is the first thing to do, and yet no one ever wants to do it, even though you get money for doing it. So it's strange. I did some work with building services energy efficiency company, and you'd go around to like a skyscraper and do an energy audit and, rank the things that they could do, like changing to LED lighting if they didn't already have that, and putting timers on things, and, making a range for your air conditioner. Instead of setting it to 22 exactly, you say it's got to be between 20 and 24. And you would then say the payback period, the economic payback period for each of those measures. And there were always some that were 6 months or less, and they would never be bothered to actually do them. And it blew my mind. It's like, this is free money. It's a topic for, you can do a whole live stream on that. And maybe I should. I understand that there's some problem between who has to do the work and who gets the money, and that's maybe part of the reason why you don't see these things happen. Okay. One more about offshore wind from Robert Sowry. Offshore wind's a hot topic in New Zealand, but it's thought to be twice as expensive to develop as onshore. And I think that's the general rule of thumb. That's what comes up in the levelized cost of energy figures, and that's what I've heard in Australia too. Do you think the extra cost is enough to stop development in New Zealand? I think it depends what your options are, and that's one of the topics that I want to get to when I get onto my other predictions for the year. I think if it was really easy to get a great renewable energy system without it, with only cheaper technologies, then you would. But there are a lot of benefits to offshore. It's not the same everywhere around the world. I know the project in Australia, the first one that's getting developed, the Star of the South, one of the most appealing things about that is that the time that the wind is highest on average in that location, it's in the afternoon and early evening. So that's when peak demand is, and when electricity prices are higher as well. And actually maybe I can show that possibly. I think I have, open NEM site. So here, let's go to 3 days and hope that the last few days will show what I've been talking about. So yeah, demand goes up through the day and peaks in the afternoon just right as solar is coming off. And also you can see that these dotted lines mean negative electricity prices. So yeah, you got heaps of solar. Solar's really cheap, way cheaper than offshore wind. But a lot of the year at the moment, especially in places like Australia and specifically South Australia, you see negative prices a lot of the time when solar's generating. And then if your offshore is mostly producing, you know, around this time, well, then that's where electricity prices have gone up. And so it might be that it doesn't matter that it's twice as expensive to develop if you're getting more than twice as much for that electricity that you deliver. And it can also, you know, help your whole system because you need less storage and stuff like that. Okay. All right, so I will just move on to my second prediction for the year, which is I think we're going to see ideas to reduce the need for adding transmission. And I have just got one article that I wanted to show. It's got a funny picture in it. So something from Renewable Economy. Social license transmission projects push community complaints to record high. And then there's this photo, someone's written in their field, piss off AusNet, which is one of the big, new transmission projects that we're supposed to be getting in Australia. And we need it because we need to add so much more wind and solar, and the wind especially is not always located right where people want to use electricity. So yeah, lots more transmission, and you see this around the world as well. It's the same in the US. You know, all of the wind resources. Great wind is in the Midwest, but that's not where people live. They live on the coast. Even in Sweden, it's very windy up in the north. People live in the south. Same in Germany, more windy in the north. People live in the south, and in basically every case, no one wants the transmission in their own backyard. So the best thing to do would be to just build those projects, but I do see that in some countries, at least, the politics of that is just going to be too hard. I mean, there have been so many protests about this transmission line, for example, and I think that they're coming a long way in terms of, getting better at compensating people who have these run through their land, and that will be part of it. But I also think / hope that people are going to start putting more value on other solutions that we can use to, get on with the energy transition without having to build as much transmission as quickly. So yeah, the first one on that is offshore wind, like I was just talking about, because usually offshore wind involves a lot less transmission than onshore, and at least if you've got transmission, or you got to put a power cable on the seafloor, obviously, but then most people around the world live close to the coast, and so you actually end up with a lot less onshore transmission. So it costs more, but you annoy less people, you piss off a lot less people. Then there might be things like community batteries or any of the domestic stuff that we talked about in the first point. I think is going to help to get, then you can combine that with distributed generation and not have to move your electricity around as far. Maybe some economic stuff like nodal pricing, so you pay more for your electricity if it's far away from where a lot of good renewable resources are, and less where it's close. And I think that sort of thing could help to bring industry to the places where the renewable electricity is. We already see that a bit happening in northern Sweden. They have built up quite a lot of industry up there where the really good wind resources are. It's my hope for Australia as well, and we're also doing that a lot in Australia and a few other places around the world, making these renewable energy zones. So this one is from New South Wales government, their planned renewable energy zone locations, and you can see there are these 4 in New South Wales and New England, Hunter, Central Coast, This one is like classic coal mining area, and I went there. A couple of my recent videos, the one on MGA Thermal and the one on Mineral Carbonation International, are both there. One Central West Arana around Dubbo, and then this one Southwest Renewable Energy Zone. And for all you non-Australians or non-New South Welsh people, I guess would be what you'd call people living in New South Wales. This is Sydney here. There's a lot of people living here. This is Canberra in here where I live. There's a few 100,000 living there. And then the rest is very lightly populated. So these zones in particular are quite far from populations, so they're going to need transmission built. But the idea of the renewable energy zones is you kind of clump it all in together, so you can build, one big chunk of like really hefty transmission for a whole lot of different wind and solar projects and batteries. So you minimize the number of people that you have to bother either by living near a wind farm or by having the transmission. And you can also hopefully find communities that are like really keen to have these projects, because of course if you've got a bunch of wind farms in the area, then you're going to need a bunch of wind turbine technicians to look after them, and so it brings jobs a lot for construction, and then still quite a lot ongoing as well. So that's another way that you can get around transmission woes. And then one other thing that I'm thinking is about like off-grid industrial areas. So I don't have a map of Australia, but if you think of a map of Australia, everyone lives over on the east coast, and then on the west coast there aren't so many people, but there is a whole lot of sunny areas, windy areas, and a lot of mining. So that's going to be one of my next points. But I think you wouldn't, if you want to take advantage of all of that renewable energy, it's never going to be cost effective to connect that to any main grid. It'd have to be thousands of kilometers of transmission. So I think that people might move to those places with good resources, in the same way that in the past industry built up around areas that had a lot of coal. Now we'll see maybe industries start to move to the places with renewables. Okay, let's see what comments we've got on that. Oh, wait, I've missed a point. It's getting very philosophical in the in the comments, which I like. I did study philosophy at university, but I can't process that fast enough to talk about now. Sorry. Okay, here's one. Procrastination has a trend of working from home change the energy usage cycles in any meaningful way. I don't know. I have seen the impact on passenger cars has been huge. So there's been a noticeable decrease in the amount of petrol that people are using, for transport. That energy for transport has gone down. I would assume that other than that, if people are air conditioning their homes like offices are air conditioned, that it would be probably worse overall. But then again, I know that I personally try really hard not to run the air conditioner. As you can see, I'm sweating. There isn't an air conditioner down here. There is upstairs, and I almost never turn it on. So answer to that is I don't know, but I would suspect that there'll be, effects both ways. Peter Russ, transmission should really be the last line of defense. I agree that it should, except that the speed that we need to go and the amount of transmission we need to build, it means that we need to be doing it at the same time as we're doing all those other things. Because I don't think that we'll get enough transmission for that last line of defense, the amount of transmission we need for that. We won't get that done in a hurry. We need to start now going as fast as we can, solve the problems with transmission so that we're able to use it as our last line of defense. But I do really hope that people do all the other stuff kind of, preferentially, but also at the same time. From M. Kelly, is there a risk that as renewables increase, the cost of electricity will fall, which makes private investment into further renewables less attractive? That sounds like what should happen. And it's been one of the kind of paradoxes of the energy transition that as we add more and more cheap renewables, because, yeah, wind and solar are cheaper than coal and gas and, yeah, other alternatives by now. But as we add more, in general, we don't see cheaper prices. And I do actually plan to get somebody on to talk about renewable energy financing, and that would be a very good question for that conversation, because it's more of a markets question than an engineering question, but it's to do with the way the market works. I mean, it's obviously the markets work differently all around the world, but in Australia and a lot of other places, you bid into the market. And I'll go back to the open NEM screen. So when you're trying to make sure that you've got enough electricity to supply based on who wants to use it, the suppliers, they bid in how much they would supply it for. And, solar is probably bidding close to zero. Same with wind. Hydro would be a bit more. Coal and gas more again. And everybody gets paid the amount that the last person that's needed said that they would supply it for. So at the moment, gas has been really expensive. So anytime you need gas in the grid, then all of the electricity at that time is really expensive. So yeah, that's my engineer's explanation about how electricity markets work and why we haven't seen this happen yet. But if you didn't need this, if you didn't need anything except for wind and solar, then yes, it should get much, much cheaper. And we do at least see in a lot of places, in Australia at least, every time you see dotted lines in the open NEM, it means that there is the negative electricity prices, and that happens whenever there's just heaps and heaps of solar in the grid. Yeah. Excuse me. From Yo, this was replying to Kelly. There should be a point of equilibrium in the middle. There's also a factor of tech becoming cheaper the more it's used, which should reduce costs and hopefully drive more investment. I think that's a really good point, and something I don't probably talk about as much as I should for how important it is. But that's the main reason why I am really optimistic about the energy transition in general, because at first it seems like, not much is happening with technologies and, electric vehicles. Their upfront purchase price is still more expensive than a petrol car. And the same was true for wind and solar until, 5 or 10 years ago. They were more expensive than coal or gas. But as you roll out more and more of the technology, then they get cheaper. And you eventually get to a point where, once it's cheaper, then it kind of accelerates and takes off. Because you can imagine by the time that the upfront cost of an electric car is cheaper than the alternative, you're not going to just have, 2 or 3% of people choosing electric cars. You're going to have most people choosing that because it's just cheaper, and, not to mention all the lifetime benefits, because you don't have to pay for petrol and not as much for maintenance and that sort of thing. So I think that this is where a lot of government programs should be targeted. They're not always, but the best place for the government to target technologies is at that early stage where there hasn't been very much adoption yet and they're still very expensive. Because the way that the price reduction works, it's with every doubling of the number of units produced. So early on, when you've only got 100 solar panels, then it's a lot easier for a government to pay for 100 to double it and reduce the cost by a certain amount. Then later on, now maybe there's a billion, and so if you want to get the same cost reduction, then you have to make another billion of them. So that's the point where you can make a difference, is early on in that curve. And I think that that's also relevant for technologies like hydrogen, carbon capture. There's a few others where the core things that they're making, most of the cost is not from anything new that's going to benefit from this, this cost improvement, because, in the case of carbon capture and storage, it's most of the cost is from balance of plant, which is like tanks and pipes and stuff, which have already, so many of them are used. You will never make a dent in the number of those systems used worldwide enough to, have it see a significant cost reduction. So it's a good way to kind of distinguish between technologies that are likely to see the same cost reduction curve as solar has, batteries are having now, and ones that aren't. Okay. Oh, we're actually already getting on in time. So I will just go now to my final point quickly. Prediction for the year, which is personal. Oh no, I just did that one. It's getting smarter with mining. So I'm hoping that we're going to see onshoring of processing with government support. So I don't think we're going to see a lot of it this year, but I'm hoping we are at the point where we're going to start to see announcements. So what I mean by that is, Australia mines iron ore, and then we ship that to China, who process it and make steel. And because iron ore is like 20 to 70% iron, you end up shipping, maybe double or triple or 5 times the volume that you would need to otherwise. So I think that a big trend for the future will be re-onshoring that stuff and, to places where there's a lot of renewable electricity in particular. So you can take advantage of that renewable energy resource and ship less. And so you can get the double whammy of reducing shipping emissions, because you're sending less ships with rocks or dirt on them. Another example would be lithium. Again, to use Australian example, Australia mines lithium rocks basically, and then China processes them into lithium carbonate or other battery precursor materials. And I think I read that, I think I have the article, generally Australian, I don't have it up here, but generally Australian lithium shipments contain only 6% of concentrate. So you can see you could save a lot of mass by a lot of shipping by doing that locally. And then the other thing is mining tailings. So a lot of mine waste contains important things that we want now in the energy transition. So and this link here from I think it's the University of Queensland website, mine waste can contain significant concentrations of highly sought after critical metals, including cobalt, rare earth elements, vanadium and indium. So those are all important for the energy transition, and I think we're gonna start getting smarter about that. And in fact, I know that there are plenty of people working on that. It's something that I'm doing a little bit of work in my real job on those kinds of projects, and I find that super exciting. Okay, so let's see if we've got any other. We've got some comments about data centers. I won't dig into that. Sorry, I'm just getting a bit lost in the comments. There's some good conversations happening in parallel. Okay. So, question from Jan H or Yana H. Why is everybody paid the most expensive price? It's the way that most markets work, I think. I'm not an economist or a financial analyst or anything, so I have to be careful about just making stuff up. But my limited understanding of how markets work, if you've got everyone selling bananas and one supplier can sell them for $1 a kilo, then everybody else is going to have to sell them for that too, if there's enough. But if there's a shortage and there aren't enough $1 a kilo bananas to go around, some you can only meet meet the demand with $5 a kilo bananas, then the person that could sell them for $1, of course, they're going to want to sell it for 5 if they can. And basically, extrapolate that onto an energy market, and it obviously depends how it's set up, but that's kind of why there's heaps of everyone around the world now is talking ways of trying to stop that. There's all sorts of different discussions in Europe, for example, about, maybe we're going to have like dual markets. There'll be one price for cheap energy technologies like wind and solar, and then a separate higher price for fossil fuels, which are more expensive. But I just kind of think it's really it's kind of weird when you interfere like that, because then you've got much more incentive to develop more of the expensive ones of the fossil fuel projects, which is kind of contrary to what you want to do with the energy transition, and also just to get the lowest price overall. I think the much better thing is to just let the high prices incentivize people to build more renewables and sort out some of the problems, with storage and all the other stuff. That's my opinion. Okay. Oh, here's a good suggestion from Oleg. Could I make a video sometime this year where I'm just catching up with all the in development technologies you made videos about last year? And I have thought of doing that before. I haven't done it partly because I've got this super long list of technologies that I've never covered yet, and that I really feel like I need to, like shipping and aviation, cement, aluminium. There's a whole lot of really important energy transition technologies that I haven't covered at all yet. So it never seems as appealing to go back and revisit, but I definitely think that's a good idea. And there's especially that some of the really early ones, because it's been 2 years, maybe even 2.5 years that I've been doing YouTube now. Some of the first ones I did were on wave energy. There's been some interesting stuff happen in wave energy recently, so that would be cool to go back and see, this company that said that they could make a device that delivered energy for price X has now made sales, or no, they've gone bankrupt, so maybe it wasn't true what they were saying. It could be really interesting. It's Colin Coates that said lots of work too. Correct. So that's another reason for why it hasn't happened yet. Okay, and then there's some good explanations, better explanations than me, about why everyone gets paid the highest cost when they're bidding into an electricity market. Robert Zari says, because no one would offer any energy to start the market. Jonathan Maddox says the marginal price for the last supply is agreed by the marginal supplier and customer, but much of the supply would be agreed in bulk in advance by bulk buyers and suppliers at a different price. And okay, maybe this is the best summary from Yo. Markets are weird because people are weird. And it all seems, I don't know, it's easier for me to imagine the actual, physical technologies, because I'm a mechanical engineer. The markets do move in mysterious ways. Okay, one more comment from Robert Zari. Am I interested in creating a video discussing installing nuclear energy in Australia? All the online resources are USA or Europe focused. I'm not super interested in it, to be honest, and that's because it is technically illegal in Australia. I don't think we need it. I don't think we'll ever get it, just because it's so easy to achieve a 100% renewable system. Without it, we'll get there much faster with wind and solar and storage, like pumped hydro and batteries. So I think it's so unlikely that I probably wouldn't. But convince me otherwise. if you would like. I did just have a couple of other quick predictions I won't talk a lot about, but I think this might be the year that we start seeing alternative battery chemistries for grid scale storage, especially, anything stationary basically, because the prices for lithium have gone up like 400% this year, and it's getting more expensive, lithium ion batteries. Another hope slash prediction is making more use of traditional hydro. So there's still a lot of hydro around the world that just, it's kind of like a one and done kind of thing. It's got water in a dam, it lets it run through a turbine, and then it's gone. I would like to see all of those converted to pumped hydro, because that's where the real value is, in my opinion, for hydro. And then my final prediction, which is maybe a bit out there, I think that Elon Musk is going to quit everything, quit all of his corporate roles and move to a private island. And this sounds a bit like the plot from Glass Onion. I don't know if any of you saw that. I saw it recently and thought, this is my favorite energy transition film, I mean. Much more so, I don't know if any of you guys watched, what was last year or the year before, Don't Look Up. I hated that so much. It took me 3 goes and I never made it all the way to the end. I just, didn't work for me, that one. But this one I really liked for the energy transition, and partly because even like they've got all these, I don't know, social media idiots in the cast, and like Kate Hudson, one character in particular. As soon as the Elon Musk type character, had his new energy type technology that created hydrogen when it reacted with air, and even the idiot characters, like, no one's going to want that in their home because it will explode. And I thought, yeah, that's maybe slightly unrealistic, because everybody seems to think that hydrogen in homes is really great. But I did think it was a nice way of, in this film universe, everybody understands that there isn't going to be a silver bullet for new energy, and there's more nuance and disadvantages to everything. So yeah, that's my bold prediction anyway. I also really hope that Elon Musk will quit all of his roles and quit messing around, because what he's really good at is, the energy stuff that he does is still good. It's just everything else that is not great. And I wish that he would be devoting his attention to the stuff that he used to do that was, making a real difference, because it's so it's so hard to see that these days, and all the carrying ons with Twitter and that sort of thing. Okay. Some comments. Musk is a workaholic, so not going to happen. Yeah, I don't know. But I just feel like he's not taking it seriously anymore. Like, he's just having a laugh, surely. That's why I think he's like just right on the cusp of like just blowing it all up and moving to a private island. I could totally see that happening. Robert Sauer agrees. Great film, great prediction. And then this one from Brian Yonker, Musk likes all the attention, and that must be true, I guess. But maybe he'll get sick of it. I don't know. Gabrielle Orzesco says, what's happening with Snow 2.0? It's still going. They had a problem where, and for people who aren't following Australia's energy transition so closely, Snow 2.0 is a big pumped hydro project in the Kosciuszko National Park. Was announced by 3 prime ministers ago, actually, Malcolm Turnbull. But there's been a lot of cost increases and a lot of delays, and now the main engineering contractor was under administration, but now it's just been bought, so it's kind of going ahead. I think that they're basically going to demand a lot more government money for it, so it's going to end up even more expensive. That's my guess, but I'm sure it will get done. I mean, they're drilling tunnels as we speak. They're not just going to, walk away from that. So I'm sure that whatever it costs, it's going to end up being done, which is probably why these private companies feel like they can, twist the arm of the government to get more money. So, yeah. Okay. Here's a good one from Oleg. No, Musk will not let go of SpaceX. It's currently a time for SpaceX where progress is slow, so he cannot do much there, and he's keeping busy otherwise. Yeah, but he's not running it, right? I mean, I'm definitely absolutely not a Musk fangirl or a Musk hater. I really try hard to ignore, and I think this is the first time I've actually ever talked about him on any of my videos, but he doesn't run SpaceX, right? That's one. He's actually got someone that knows how to run a tech company in there running it well. That's my understanding, and I hope that he will. I hope that he will roll out that approach elsewhere. Okay, so yeah, I want to wrap up now, kind of running through the time, but I just wanted to talk a little bit about my personal goals for 2020. Those of you who watch a lot will know that, 2022, that's the year we just had. I was pregnant the whole year and then had a baby, so I'll be working less this year because of that. But actually, my 2021 was very disrupted anyway, because it turns out that for me, being pregnant was a lot harder than actually having a baby. So I need to thank my couple of teammates, Kevin and Harvey, for carrying most of the load while I was working very little, and I was being very annoying to work with. So Kevin does the research and the engineering calculations, and Harvey does the editing. And yeah, for anybody that can see that the quality has improved, and we still put out quite a lot of videos last year, that's mostly thanks to those guys. So ramping up hopefully a bit with the YouTube this year. My goals are twice monthly live streams all year, and I'm starting the year out well. The next one's going to be, I'm doing an update video on the levelized cost of energy video that I made a little over a year ago. You might remember it. It had a race car analogy. Let's see. Yeah, it's this one here. So we're doing an update on that, and then I'm going to get John Poljak, who did all the calculations for that video. He's going to be on a live stream the week after, so we can talk all about all the assumptions. And this time we're adding in geothermal and nuclear, and also energy storage and transmission, talking about all of that together. So look out for that in the next couple of weeks. And yeah, other YouTube goals, I am hoping to get a writer on board on the team. So if you know anybody, then let me know. The team that I have currently, they're both engineers who also like doing the other stuff. So that's kind of perfect. It's really hard to get a non-technical person on the team. And it is also really hard to find an engineer that can also write well and communicate. So if anybody knows someone that fits that very specific very specific category, then please let me know, because that will help me to fulfill my other YouTube goal, which is fortnightly regular videos, hopefully by the second half of the year. I'm also keeping my consulting business going. I'm working on energy technology development and due diligence and stuff related to that. And I'm also excited, I'm going to be working with a minerals processing company that's related to battery manufacture in Australia. So that will be really cool to get more into that. Okay, so thank you everyone for coming and watching. It's all that there is time for today. And of course, thanks to WeatherGuard Lightning Tech for sponsoring this live stream. And I wanted to show you somewhere here. Yeah, I actually have some of the strike tape here. I just saw it on my desk and thought that I might as well show that. So I actually have plans to work with the WeatherGuard founder, Alan Hall, who I do the podcast with. He's going to help me make a video on lightning and wind turbines, and we'll do a live stream as well. So that should be very interesting. WeatherGuard also have a great tech newsletter and a podcast, which I co-host with Alan Hall and Joel Saxum each week. The links are in the description. We talked about all kinds of clean energy tech news, and the latest one that's out now, I was actually on holiday, so I'm not in it, but Alan and Joel talked about a couple of new installation and maintenance techs. So check that out on your favorite podcast app or watch it here on YouTube. And of course, finally, I also need to always thank the Patreon community. You can join us at this link if you would like to. It's a really great team that we have now with the Patreon group, and the financial support helps to keep the channel turning over, keep it professional, hopefully getting more professional. And More so than that, though, is the community and the discussion definitely helps make the videos better. So thank you very much. And yeah, that's all for today. And I'll see you. I've got a video coming out within a week and then a live stream a week after that. So I'll see you then. Thank you. Bye.